Hello again, my dear students from everywhere. In this part, we'll keep on going and speaking about the measurement in chemistry. This is the second importance of studying the measurement. The second importance of the measurement is it's necessary for monitoring the health and in health protection. Monitoring not in just the health, monitoring everything. So measurement is necessary for monitoring the values of many things in our body, in the nature, and it helps in the protection. Okay. So now, to keep the environment safe and to protect the environment, that requires the drinking water monitoring the drinking water. That means the water we are drinking must be clear and free of pollutants, there is no contaminations, and drinkable water. The second thing to say to keep the environment that we are living in, and it's very important to us because the environment is the place we are living in, is to keep the air pure. To keep the air pure means to monitor the components of the air, the atmosphere, and see the purity and to measure the purity of the air we breathe. The health of the food, substances, and the agricultural products must be monitored too. The health of the food, substances, and the agricultural products must be monitored too to make sure that the food and these agricultural products are sufficient and are healthy to us, not harmful. These are very important things to keep the environment safe, the environment, the place we are living in, to keep this place safe and to protect our environment. Use the following table, which shows the international standards of the drinking water components to examine the quality of the water in the two previous bottles. In the two previous bottles, bottle A and bottle B, there are minerals. And in this table here, shows the international standards of the drinking water to make sure this water is drinkable and is potable, healthy to us, can be used by the human. So here, the components must of the water, the concentration of sodium ions in the drinking water must be less than 150. So which bottle here is containing or agreed with this standard? Actually, both of them are can be accepted in the concentration of the sodium ions because bottle A has 25.5 milligrams per liter of sodium, and the bottle B had 120 milligrams of sodium ions per liter. So each of them are less than 150. So the concentration of sodium in each bottle is accepted to be inside the water we are drinking. Also, here, second component is the calcium, the potassium. The potassium ions must be less than 12. So as you can see here in bottle A and bottle B, both of them has concentration potassium concentration is less than 12 milligrams per liter. So they are accepted to they succeeded in this comparison. So here the magnesium concentration must be less than 50, and as you can see here, both bottles have concentrations of magnesium concentration less than 50 milligrams per liter, and the same for each of them. Let's see the chlorine. The chlorine ions must be between 200 and 250. And in the first bottle here, bottle A, in bottle A, you can see here, it has 40.2 milligrams per liter of chlorine ions. That means this is not agreed with the standard here, so that can make the water is not or can be drinkable. But I want to mention something very important here. The chlorine ions can be existed in many forms in salts, for example, like in sodium chloride, okay? But the chlorine here may be referred to the chlorine used to kill the germs. So sometimes the factories that produce the water to us using some source of radiations like the ultraviolet radiation to kill the germs instead of using the chlorine. So we can say here these are the both of them can be accepted as a drinking water. Even this first bottle A, has less concentration of chlorine than the international standard criteria. Okay, okay. And the sulfate concentration is less than 250, so both of them can be accepted as drinking water. So from the previous tables, we can conclude that the two bottles are valid for drinking. We can drink from each bottle. The third importance of the measurement. The measurement helping in diagnosing and suggesting solutions. Okay, diagnosing and suggesting solutions or and suitable medications in the case of defect. Defect means when the person gets a disease infected. So in the case of disease or in the case of defects, measurement helping in diagnosing the case, the situation, and produce solutions and suitable medication. Here he's saying that the medical analysis reports indicate the health status of patients, referring to the medical analysis values of healthy person. Referring to the medical values, the medical analysis values of healthy person. The healthy person values can be referred to by the reference values. The reference values. So in this table, we can see the reference values or the values of the healthy person that we are using to compare or to determine if we are healthy or we have some defect or diseases. Okay, so the medical analysis reports indicate the health status of the patient, referring to the medical analysis values of healthy persons, which are known as the reference values. So this table shows the reference values. Use the opposite medical analysis report to clarify the following. Number one, what does the reference value mean? As I told you, the reference values are the values of the healthy persons. The reference value means the normal limits of the lowest and the highest values obtained by normal healthy people. So these are the values of the normal healthy peoples. And in this reference values, there is a range we can determine if we are healthy or patient from. Like here, for example, in the glucose, you can find the reference values, which are the values of the healthy peoples. We can see the lowest concentration of glucose in the blood of the healthy people and the highest or the maximum concentration of the glucose in the blood of the healthy people. So the reference values shows us the reference value shows us the limits of the lowest and the highest values obtained by normal healthy people. Number two, what is your conclusion about these results? The results of the person, the values of the analysis shows the values of the person, of the patient, okay, the patient. So these are the patient results. Great, great. And these are the reference values. here. So what these values of the analysis refer to? We can conclude from this table this person has an accepted limits or accepted concentration of glucose. So the concentration of the glucose for this person is accepted or is normal, while the concentration of the uric acid in his blood is what we can see here. The limits or the range of the uric acid must be between 3.6 to 8.3. So he has 9.2, means he has more more uric acid, or the concentration of the uric acid in his blood is more than the normal people. So he is suffering from problems. There is a problem here. There is a problem. Okay, and he must see the doctor. The amount of the glucose is normal, but the amount of the uric acid is abnormal. Abnormal means not the opposite of normal. Abnormal means not agreed with the reference. So the uric acid is abnormal because it's higher than the highest reference value. Number 3. What are the decisions that this person has to take? He must see the doctor to take the proper medication and do the medical analysis again to see how the treatment is working, After having the medicine, he must do and redo the analysis to make sure that the medicine is doing the job in a good way and solving the problem. Okay, so now we're talking about the measurement system and its units. So did you hear before about the SI system? The SI system refers to the international system of measuring units. So something international means something unified. Every country around the world agreed on using these units in measuring things. For example, for measuring the length or the distance, we are using the meters. For mass, we're using kilogram, and the time we're using seconds. These three are the fundamental quantities forming the MKS system. But the SI system added more quantities to measure and used the Kelvin to measure temperature. So to measure temperature, we are using the Kelvin. For measuring the intensity, the intensity of the electricity, we're using the ampere. And the quantity of matter, we are using the mole. And this is a unit we'll discuss in with details, and we'll learn more about in the second unit. And for the luminosity, we are using the candela, and for the quantity of the electricity, we're using the column on the name of the scientist, column. Okay, here in this picture, I wrote for you the prefixes and the suffixes that we are using to work in the SI units. The idea of the SI unit is to use some prefixes to be existed before the unit, the base unit. We're putting the base unit here, and put a prefix here, prefix. So the prefix existed before the unit. It changes the quantity of the measuring unit. It can increase the measuring unit or decrease it. That depends on which prefix we are using. So these prefixes are divided into two divisions. Multiples, which are magnifying or increasing the measuring unit, and submultiples, which decrease the measuring units. And in the SI system, we are dependent on the base 10 unit. We are using 10 to the power of number. This number can be positive and form multiples which increase the measuring unit, or can be negative and they refer to the submultiples which decrease the measuring unit. So this is the idea of the measuring system. Let's see it here. For example, if we have the meter and this is the base unit, we wanted to measure something is very great, something is very long. So let's just say we're measuring a road or the street length, then we're using something called the kilometer. Kilometer is greater than meter by 1,000 times. So 1 kilometers equals 1,000th meter. Okay, this word kilo, the kilo, refers to 10 to the power of 3. Okay, let's just say we are measuring something that's very tiny, like the length of the tip of our pencil. Then we're using something like millimeter. Millimeter, the word milli, refers to 10 to the power of minus 3. So this is submultiple and decreases the meter. So the millimeter is less or smaller than meter by 1,000 times. That means 1 meter equals 1,000 millimeters. And the 1 millimeter equals part of thousand of meter. Great, great. So this is the idea of the SI system, the SI units. We will discuss the SI units and how to convert between unit to another in the second chapter in this unit. I actually have produced a video talking about this before, but it will be accessible online in the few common days. So just wait, and everything will be clarified for you in the next chapter. Now let's talk about the requirements of any chemical laboratories. Any laboratory you have gotten or you will get in contain main four things. These four things must be existed in any chemical laboratories. Okay, these four things. The first thing is the safety precautions. This is a label, will be attached on the wall, maybe on the door, tell you what to do in the case of getting some assets on your coat, or something have been dropped, or something or if there's a fire, what will you do? These are the precautions that must be existed in any chemical laboratory. The second thing is a source of water. So water is very crucial in the chemical laboratories. Number three, a source of heat. A source of heat may be a Bunsen flame, or maybe like a heater. So these are heat sources. Number four is the cupboard, a cupboard or shelves. Why we need cupboards or shelves in the chemical laboratories? To store things. These things are chemicals, tools, and the apparatus. Okay, and you must know how to use these tools in your chemistry laboratories. Number one, we have the first device, which is the balance. This is a device or a tool, and it's used to measure the mass. You know, the mass of anything need to be measured, and we are using the balance to measure it. This type of balances are called digital balance. The most common type of balances in any laboratories is the sensitive balance, the digital sensitive balance. And the most used type is the top loading balance, which has a metal surface here, and the matter will be put on this top, and the results or the mass will appear on the screen, on the digital screen. So we need the sensitive balance to determine the mass of the substance. And the most common type is the digital balance. And the most used type is the top loading balance. Great. Now let's talk about the second device. The second device is the burette. And the burette is a long glass tube. You can see its picture here on the right side. It's a long glass tube and they have a graduation. This glass tube has two openings, upper one and the lower one. Beside or near the lower opening there is a valve. The graduation starts from the upper opening and ends near to the valve. And this valve is used to control the amount of the solution that we will take from the burette, the amount of the solution released from the burette. Okay, so the burette will release the solution from the lower oven. Okay, that's great. So the burette is a long glass tube made of glass, has two openings. Upper one and near it there is the zero of the graduation. From the upper opening, we fill the burette with the solution. So you pour the solution from the upper opening. And this is a narrow opening, so we are using a funnel. And the lower opening has a fixed valve near to it here, which is used and control the amount of the solution released from the burette. The burette is fixed on a holder. This thing here, this metallic thing, which has a metallic base, it's made of metal to be heavy and not be moved during the experiment, is used to fix the burette in a vertical shape. So we need the holder to preserve the vertical shape or the vertical position of the burette during the experiment. In the burette, the graduation, the zero is close to the upper opening, and the end is before the valve. Here is the end of the graduation. So the devices that are driven water from the lower opening have a graduation, start from near the upper opening and end near the lower opening. Any device burin or drop the solution from the lower side or the lower opening is had the graduation or the end of its graduation is near to the place that released the solution from. Okay, any device. That's great. So we can say that this device is used for a specific usage. The usage of the burette is to determine or to measure the volumes accurately, the volumes of the solutions. So we are using the burette to measure the volumes of the solutions accurately. But why we need the burette exactly? The burette is used during a kind of experiments. It's called the titration experiments. And it's a kind of experiments used to determine the concentration of solutions. So the usage of the burette is to determine the volumes of solutions with high degree of accuracy. High degree of accuracy. Okay, great. The volume that the burette is measuring, the volume, is not the volume of the solution inside the burette. But we can determine the volume of the solution inside it, but it is not the main function. The main function or the main usage is to determine the volume of the solution that released from the burette. Okay, the amount of the solution taken from the burette. In titration, we also need another device which is called the conical flask. The conical flask. Okay, we'll talk about it later. Okay, So we know that the balance is used to determine the mass, the burette is used to determine the volumes, especially the volume of the solutions that released or taken from the burette, and the burette need a holder to keep it vertical during the chemical experiment. And we said that any tool has two openings. The place that the solution is released from is the place where the end of the graduation. So here the solution is released from the lower opening, so the end of the graduation is near to the lower opening. Let's keep going. Now let's talk about the beakers. Beakers is another device in the chemistry laboratory. It's a container made of glass container. We are using it to fill it with the solutions, to transport it, to store it till the need, and to mix the solutions in liquid. Also, we are using the beakers in measuring the volumes approximately, and the focus on approximately. That means the volumes of the liquids that we get from using the beakers is not the true or the real volume, but it's near to the real value. It's not accurate, but approximate. The beakers are made of Pyrex because Pyrex is a type of glass that resists the heat. It has resistance to the heat. So when we put the beaker on the Bunsen flame on a source of heat, the beaker will not explode because it's made of Pyrex which resists the heat. Beakers has graduations. A graduation of any device has one open. The end will be near to the only open that the device has. As I told you before, any device has two openings, like the burette. The end of the graduation will be near to the open that release the solution. So in the burette, the end of the graduation was near to the lower opening because it was the opening that released the solution. While in one opening apparatus, there is no other opening, so the end of the graduation will be near to the only oven existed in this device. In the beakers, the graduation started from the bottom till the upper side, from the down to the upper side. And we are using the beakers to mix solutions and liquids, to transport known volumes of liquids, and to measure the volumes approximately. Another device and is used to measure the volumes is the graduated cylinder. From the name, it has a graduation, and it's a glass tube. A glass cylinder has only one open, so the end of the graduation is near to the only open existed in this device, and we are using the graduated cylinder to measure the volumes of the liquids and solutions accurately. Accurately means the results are exactly the same of the real results or the real value of the solution. And we can use also the graduated cylinder in measuring the volumes of solids, the solid body. Which solid body? The solid body that doesn't dissolve in water. And you can say, Mister, I know that the graduated cylinder can measure the volume of solutions in liquid, and I understand that, and I know how to do that. But how to measure the volume of solids using graduated cylinder? Actually, there is an easy way. We are using the graduated cylinder to measure the volume of certain volume of liquid, and let's say this is graduated cylinder filled with water, and the volume of the water existed inside this graduated cylinder now is 30 milliliters. So when we want to determine the volume of this solid which doesn't dissolve in water, we will add it inside this graduated cylinder. Okay, so it's down here in the cylinder now. So after adding the body inside the graduated cylinder, the level of the water elevated up and raised up and became 50 milliliters. So after that, we can determine the volume of the solution by subtracting the previous volume of the liquid before adding the body from the new volume, which is 50, which is the volume that we have after adding the body. So the volume of the solid equals 50, subtracted 30 equals 20 milliliters. But focus on something very important here. The milliliter and the liter are units used to measure the volume of what? Of liquids. While when we are measuring the volumes of solids, we are using another volume unit, which is called the cubic centimeter. So cubic centimeter equals the milliliter. So the body here, the volume of the body is 20 cubic centimeter. I will clarify this point for you here. This is for knowing, okay? Just information for knowing. The 1 liter equals 1 cubic decimeter, and the 1 milliliter equals 1 cubic centimeter. Also, 1 meter equals 1,000 liters. 1 cubic meter equals 1,000 liters. Okay, that's good. We are using graduated cylinder and measuring the volumes as I told you. But how we do it? We are doing it by reading or recording the reading of the lowest or the lower point of the convex surface of the liquid in this graduated cylinder. Which convex shape we are talking about now? When we have the graduated cylinder like that, and they add solution inside it, and they put a solution inside it, the solution take a convex shape like that. Okay. Here, to get the volume, determine the volume of this liquid, you need to determine it. Maybe you will be confused because there are two places inside reached by the liquid. The lower one, let's say it's 90 milliliters, and the higher one, which the edges of this convex refer to, is 91 milliliter. So what is the right volume of the solution? The right volume, as I told you here, is the lower point of the convex surface. So there is the convex surface, which we are calling sometimes the meniscus. The meniscus means the convex surface. The lowest point, the bottom of this meniscus or the convex surface, refer to the right volume of the solution. So the volume of this solution is 90 milliliters. The fifth device with us, the fifth equipment, is the flask. There are several types of flasks depending on the usage of this flask. For example, here we have the conical flask, which is used in titration, as I told you before. Another type of the flasks is the round bottom flask. Round bottom flask, from its name, has a rounded bottom and is used in preparing and distillation. So when the question tells you a device is used in distillation, automatically your answer will be the round bottom flask. Another type is the volumetric flask. Volumetric flask is a flask with a mark showing us the capacity of this flask, and it's used in preparing solutions with accurate known concentration. The solutions with accurate known concentrations are called standard solutions. So this volumetric flask is used in preparing standard solutions. There are flasks. These flasks can be seen here. Here is the conical flask. It's made of Pyrex glass and is used in titration. To be used in titration, we have a graduation here, give us the volume of the solution inside it, but approximately. The second type is the round bottom flask, which is a flask too made of Pyrex glass. And it must be made of Pyrex because the Pyrex is the glass that resists the heat. And the process of distillation, which is the usage of this device, need as a must a heat. So distillation is the process in which there is a liquid inside the round bottom flask and there is a source of heat boiling this water. So the water inside the round bottom flask will boil and evaporate. The evaporation will be condensate. The evaporated water will be condensate on a surface and collect in a container. Then this water inside the container is called distilled water. Distilled water, okay? So distillation is a process require heat to evaporate the water, and after that we will condensate the water evaporated and collected collected water in another container. So it's made of the Pyrex glass. Volumetric flask is the last type of the flasks here, and as I told you, it has a mark, as you can see here, determine its capacity. We can use the volumetric flask and determine the volume of the solutions accurately, but make sure of not conflicted between the volume which it is measuring. The volumetric flask measured the solution after adding sufficient amount of the solution to reach the mark near to the oven. So if we put the water till this part, for example, then we will not be able to determine the value. The solution which we want to determine its value must fill the volumetric flask till the mark here. Okay, then the volume will be equals the capacity of this volumetric flask. Okay. Now we still have two devices, two equipment to speak about. The first one is the pipette, and the second one is the pH meter. Okay, great. Let's start with the pipette. Pipette, as you can see in the picture here, this man pointing to a longer glass tool, has a narrow diameter, and this glass tool has two openings, one here, one lower open, and the upper open. The upper opening is attached to a tool is called a suction. Sometimes you put this tool to this open, the upper one, to insert the solution from the lower oven by vacuuming the pipette. So after vacuuming the air from the pipette, the solution started to be slided in or inserted inside the pipette. I mean the solution will replace or will take the place of the vacuumed air or the air that you have vacuumed. So when you vacuum or take the air away from the pipette, the solution started to fill the free place inside the pipette. Sometimes we don't have this suction tool, so instead you can put your mouse here to vacuum the air from this pipette. So the pipette is a long glass tool, looks like the burette a little bit, and it has two openings, upper one and the lower one. The upper one is to suck the solution inside the pipette to vacuum the air from the pipette and this insert the solution. So you can use your mouse or a suction tool, something like that one or that huge one here. And the lower opening of the pipette is used to do both of the jobs, insertion of the solution and releasing of the solution. So you can insert the solution from this oven, the lower one, and after that you can use it to drop the solution out of the pipette. Okay, great. Now let's see the graduation on the pipette. Here, the pipette is a longer glass tube, opened from the two sides. Recorded on it its volume capacity. So you can see here, number 10 here, refer to the capacity of this pipette. That means this pipette, the pipette capacity is 10 milliliters, sorry, 10 milliliters. Fine. And here is the graduation. As I told you before, the graduation of any tool opened from two sides has upper opening and lower one, upper opening and lower one. The end of the graduation be in the place or near to the open that releasing the solution. So in the pipette, this oven is the oven that is used to insert and release. So the end of the graduation will be here, exactly here. So here is the 10 milliliter, the end of the graduation, and here near to the upper oven is the 0. And that remember you with the burette, because we said that the burette is a longer glass tube with two opening, and the end of the graduation is near to the lower opening. But how to control the amount of the solution released from the pipette? Actually, in the same way, we are controlling the amount of the solution inserted inside the pipette. To insert the solution, we were pressing on the suction tool to push the air away and release our hand so that the solution started to replace the air. Now the pipette is filled. To release the solution from the pipette, we are started to press again on the suction tool. So pressing on the suction tool release anything inside the pipette. Release the air, push the air out of the pipette, or push the solution out of the pipette. As you press harder, the solution starts to go out faster. This is the technique, okay? If we are using our mouse, we started to prevent the solution from getting out of the pipette by blocking this oven with our thumb. You put your thumb on this upper opening after filling the pipette with the solution, so the solution will stay inside the pipette and will not go out. And to release the solution out, you started to move your thumb up to allow the air to start to fill the pipette and push the solution out of the pipette. These are how to use the pipette in the laboratory. Let's start to talk about the usage at first. The usage of the pipette is to measure the volumes of the solutions accurately. Okay, it's a very accurate device used to measure the amount of the volume of the solution. But we use mainly this tool in transporting certain volume of the solution. So we can say the pipette is used to measure certain volume of solution and transport the solution, or to measure and transport certain volume of the solution. Okay, because as you can see here, we can take certain amount of this solution from the beaker, and now the volume inside this pipette is accurate, and start to drop the solution inside another container as you need in the experiment, drops by drops. So you start to transport the solution from the beaker to another one, but with a certain volume, accurate volume. This one in the black picture here is another type of the pipettes, but it's called a dropper. From its name, the dropper is used to drop or to release drops of the solution, and this is a small graduation because you're just using it to transport drops, one drop, two drop, so you are treating here with drops, so we are calling this pipette as a dropper, while here it's the normal pipette. Okay, this is a pipette. This kind here of pipette has a bulb, so we call this a pipette with a bulb. Here the number of the bulbs are 2, so this is a pipette with 2 bulbs. The next number written on the pipette is this small number, 0.1, and sometimes you can find it written 1/10, 1 divided by 10. That means the error percentage is 1/10. The error percentage is 1/10, positive or negative 1/10. So the amount of the solution measured may be more by 1/10 or less than by 1/10 than the number you have recorded on the graduation, and that depends on the error that we have talked about earlier in this lecture. So again, the pipette is a longer glass tube opened from two sides. The upper one is to start to vacuum the pipette, and the lower one is used to both inserting and releasing the solution. And there is a number recorded on the pipette showing us the volume, capacity, and the error percentage. The volume, capacity, and the error percentage. That one is the volume capacity, and that one is the error percentage. Great, very good. Here it is telling you that error percentage, the error may be reduced from the apparatus used or the circumstances, means the situations, or the usage, and also from the human errors. These are the errors that we have talked about earlier. This is a graduated pipette, and this is a pipette with 2 bulbs. The usage is to measure and transport certain volume of a solution, or to measure and transport accurate volume of the solution. The way of usage, as I told you, some of them are filled by mouse sucking, so you're vacuuming it by mouse sucking, and this must be with care to not swallow the solution by a mistake. The others are supported with the sucking tools, and we mainly use them in the very hazardous material like acids. Okay, very great. Let's now move to the second and last device in our lecture, which is the measuring tools for the pH value. We have 2 devices or equipments we are using to determine the pH of the medium. The pH refers to the concentration of the hydrogen ions in the aqueous solution. And as you know, the acid and the base or the acid solutions has high concentration of the hydrogen ions. You have learned that the acid is the molecule or the solution that has hydrogen atoms and loses the hydrogen in the medium. So it is ionized to have hydrogen atoms, positive hydrogen atoms, and the chlorine negative. You have learned that in the laboratory stage. This is an acid, hydrochloric acid. That's why we need something to determine the concentration of the solution and tell us if this medium is acidic, basic, or alkaline, as you can call it, or neutral. The pH meter. The pH at first refers to the concentration of the hydrogen atoms, we can call it the proton ions, in the aqueous solution. its value ranges from 0 to 14. The value of the pH starts from 0 to 14. So the range starts from 0 to 14. And we divide it into two parts, 0 to 7 and from 7 to 14. From 0 to 7, we are calling it acidic medium. From 7 to 14, we can call it basic medium. And at 7, we are calling it neutral medium. So from 0 to 7, this is an acidic medium. And the strength of this acid increases as we go to near to the zero. As we go near to the zero, the acidity of this medium increases, and the basicity increase as we go to near to 14. So here the basicity increase and the acidity increase as we near to the zero. And the solution can be neutral at 7. So the number of the hydrogen atom or the concentration of the hydrogen ions equals the number of the hydroxide ions, as we can see in the water H2O. It consisted of hydrogen positive and hydroxide ion negative. Okay, so the water is neutral here. And for knowing that the water in the pure state shows a little phase of acidity. Now let's keep going. So as I told you, if we go from 7 to 0, the acidity increases. So the solution is acidic if the pH is smaller than 7. And if the pH is greater than 7, the solution is called to be basic, and we can call it alkaline. And if the pH equals 7, it's neutral. The determination of the pH is very important in the chemical and biochemical reactions. Now let's talk about the devices. The pH test paper tape. The pH test paper tape. These tapes are tapes filled or saturated with indicator, okay, and dried. So we get this tape, immerse it in an indicator, so it will be saturated because it's a porous. So it's a porous paper, it's a paper has pores. We will fill these pores with indicator. So the indicator will fill these pores, and this tape will be saturated with the indicator. After that, we will dry this paper, this tape or this paper. So we can call it later as the test paper tape. Sometimes we call them as litmus paper, but that depends on the indicator. If the indicator is the litmus, so we can call this paper as a litmus paper. Okay. So the test paper tape is a tape or a paper, a porous paper, saturated with indicator and dried. Then when we immerse the paper in a solution, the color of this paper starts to change, and this color indicates the certain pH value. When you immerse your paper in a medium, the color on this paper, as you can see here, it's orange. When we immersed it, it got the green color. So the color changed. After that, as the color changed, we will compare our color with a table contains different colors. Each color refers to a number of the pH. So we have here this green one and this almost like that one on the reference table. We will compare between them. Then our pH here is 7. When we know that this green color refers to 7 pH, then we understand that this medium was neutral. That was a neutral medium. This is the technique. Another device is the pH meter. The pH meter is a digital device, has a digital screen and a ball. When we immerse this ball in the solution or in the medium we need to determine its pH, a number starts to appear on the screen. This number shows us the acidity and the basicity. So here this medium pH is 3.2, and that means it's less than 7, so it's an acidic medium. Okay, it's great. So the pH meter is more accurate digital apparatus, more accurate than the pH test paper. And when it's immersed in the solution, the pH appears directly on the digital screen. Again, we have two devices. The first one is the pH test paper, and it's a paper, a porous paper, saturated with an indicator and dried. So now this orange paper, this orange tip of this paper is a paper saturated with a solution, with an indicator. When we immerse this tip or this paper inside this beaker, and we need to determine its pH, its acidity or basicity, to know if it's acid, base, or neutral, we immerse this paper or this tape inside this medium. The color of this orange place will change and will turn to be another one. Here it became green. We have a reference table. We can use it to understand the color. This color telling us that the pH here is 7. And as we know, when the pH is 7, this medium is neutral. The second device is the pH meter, which is a digital device more accurate than the test paper, and it has a ball and can be immersed to the medium, and the pH will start to appear directly on the digital screen here, and this is more accurate.